Welcome to the continuation of Algebra, where we look at Factorization 2. So far, we have looked at common factors or the type of factorization called common factors. In this video, we're going to take a look at difference of two squares. Then in the next video, we'll look at factorization that involves 4 terms, and then we'll end with quadratic expressions. So what is difference of two squares all about? So a square is any term that has a square root. Okay. The difference of two squares are expressions where there are two squares separated by a minus symbol. So in difference of two squares, there is a minus symbol in between. On the left, there is a number which is a square, and on the right, there is a number which is a square. Or there is a term which is a square, which can be a variable, a number, a combination of a variable and a number, and the likes. Okay. So usually these expressions cannot be factored using the common factor approach. So let's say we have x squared minus y squared, x squared minus y squared. We can see that here that the first thing is we have minus. Always, for you to do difference of two squares, you should have minus somewhere. Okay, so this one is x power 2 and this one is y power 2. So any variable that has a power which is an even number, or where 2 can go without a remainder, it's a square variable. It means it has a square root. Okay, so this one is power 2, so 2 can go into 2, therefore it's a square. Okay, or in short, any variable that has power 2 is a square. Okay, so this is a square, there's a minus, and this one also is a square. So these are two squares and there's a minus, which makes this to be difference of two squares. Another one is 9 minus x squared. X squared, it is to tell. What about 9? Does 9, do we have a square root for 9? Yes, we do, 3. Okay, so if a number has a square root, then it is a square. So in short, for letters, you look at the power. If it has power 2, then it's a square, or if it has any other power where 2 can go into without a remainder, it's a square. Then for numbers, you ask yourself if the number has a square root. That's why it's very important to know the square roots of numbers from 1 up to 25. Okay, or actually for square roots, you have to know the square roots up to 625. Okay, 625. Or you know the squares of numbers from 1 to 10, like 1 power 2. I mean 1 power 2, you get what? 1. 2 power 2, 4. 3 power 2, 9. 4 power 2, 16. 5 power 2, 25. 6 power 2, 36. You need to do the same up to 10 power 2, which is going to be 100. Okay, when you do that, it will be easy for you to know the square roots of some numbers, because the square root of 4 is 2 and the square of 2 is 4. Okay, the language there, the square root of 4 is 2 and the square of 2 is 4. If you have done indices, you must be familiar with this language. So x squared is a square because x times x is x squared. Just a summary of what I'm saying. Also, y squared is a square because y times y is y squared. And 9 is a square because 3 times 3, it's a 9. So a squared minus b squared. A squared minus b squared. How can we factorize this? So the first step is to write without the power 2's, or to write in terms of the square roots. So you can think of it as writing without the power 2's, or writing in terms of square roots. What's the square root of a squared? It's a. And what's the square root of b squared? It's b. So write the way they are inside the brackets, like so. Okay, then again you write the way they are, but where there's minus you put plus, like so. Okay, you are factorized. We go to b. X squared plus y squared. How can we factorize this one? Since there is plus here, there is no minus, we cannot factorize. Okay, if you think of it in terms of common factors, There are no common factors here. There are no common factors. Then again, there is no minus. Okay, yes, these are squares. X squared is a square and y squared is a square, but there's no minus, so it's not difference of two squares. So in short, always we should be having minus. Okay, so with that, we can't factorize this one. Let's say there was a minus here. How can we factorize it? If it was like this, x squared minus y squared. So again, we write without the power 2, and here without the power 2, as in x minus y. Then again, we write another set of brackets with plus instead of minus, like this. We have factorized. What about C? 4 minus y squared. So 4 minus y squared, we can write y squared without the power 2. But for numbers, of course, you can, if you want, express 4 with a power 2. Like you write 4 as something to the power 2. Okay? Something to the power 2 such that what you get is equivalent to 4. What do I mean? I mean something like this. 2 power 2 is 4. Okay, so in short, you write the square root of 4, but with a power 2, because 2 power 2 is 4. So it means we haven't changed anything other than the way to write here. So the square root of 4 is 2. So 2 to the power 2 is 4. So we have just written 4 in a different way, minus y squared. Okay, so from here, we can write without the power 2's. So it's going to be first set of brackets 2 minus y, the second set 2 plus y. Another way to think about it, when it comes to numbers, just write the square root of the number. The square root of 4 is 2. So we write 2 minus, then the letters we write without the power 2. So it becomes 2 minus y. And again, we write 2 as 2 plus y. Let's look at another question, F, so that you understand better. Sorry, I mean D. So D, it is a power 4 minus y power 6. As you can see, we don't have 2's. So how do we deal with this? Is this a square? Yes. So long as the power 2 can go into that power without a remainder, it's a square. Even this one, 2 can go into 6 without a remainder, it's a square. So this kind of question doesn't come that often. Maybe I've seen it once in my life, but you need just to be ready for it. Okay, so a power 4 minus y power 6, you can divide 4 by 2, it will give you 2, and y by 6, and 6 by 2. So you divide 4 by 2, you get 2, 6 by 2, you get 3. So it will be like this. Okay, 4 divided by 2, it's 2. So we have a power 2. Then the 2, we write it outside. So that, again, if we look at it, 2 times 2, it gives us back the 4. So we have just written a power 4 in terms of its square root. The square root of a power 4 is a power 2. Okay, so a recap. So you divide the power by 2. So 4 by divided by 2, it's a power. It's 2. So this becomes a power 2. The 2, you write it outside always. Here again, 6 divided by 2 is 3. So it will become y power 3. Y power 3, again, outside the brackets, we always write the 2. Okay, so you write a power 4 in terms of its square root and y power 6 in terms of its square root. The square root of a power 4 is a power 2, and the square root of y power 6 is y power 3. The power 2's, you always write them outside. And finally, we can do this now. So we write without the power 2's. So this becomes a power 2 minus y power 3, and this one becomes a power 2 plus y power 3. We got question E, 4x squared minus y squared. Now it's becoming a bit more complicated, as it may seem. X squared, we know we're going to write it without the power 2. Y squared, we're going to write it without the power 2. What about 4? 4, we write it in terms of its square root. Remember, numbers I said you write them in terms of their square root. So 4, we write it as 2 to the power 2. Actually, everything you write them in terms of their square root. It's just that for letters, it's easy to understand the way of just letting go of the 2 or writing without the power 2. Okay, but for numbers, since it doesn't have a power 2, if you want, you can write it as 2 to the power 2. Okay, so in short, 4 becomes 2, x squared becomes x, y squared becomes y. So it's 2x minus y, and this side 2x plus y. Okay. We go to f. So f is 4x squared minus y squared. Okay. So again, sorry, f is 4x squared minus 9y squared. F is 4x squared minus 9y squared. So the 4 becomes 2, x squared becomes x, negative 9 becomes negative 3, y squared becomes y. So it will be like this, 2x minus 3y, 2x plus 3y. We go to g. G is interesting, x squared minus 1. So x squared, we know we're going to write it as x. What about 1? What is the square root of 1? It's 1. The square root of 1, it's 1. 1 times 1, it's 1. So it's going to be x minus 1 in brackets and x plus 1 in brackets. We got h, half power 2 minus y power 2. So this at first may be intimidating, but it's not, because this has a power 2 and this has a power 2. So we just remove the power 2's. It's going to be half minus y in brackets and half plus y in brackets. So there's a question that tends to come in an exam. It's like this one here. So it says factorize completely 2x squared minus 50y squared. 2x squared minus 50y squared. Okay, so they can just say factorize, then they write this, but they added this word. Why? There's a reason why they added this word. It's because you can factorize this, but without finishing the factorization. In short, it involves more than one type of factorization or one stage of factorization. So how do you factor out 2x squared minus 50y squared? Of course, when you just look at it, you can see the minus and you can see the power 2's, and you can tell that this is difference of two squares. Or is it? If you look at 2, is it a square number? No. 2 has no square root. What about 50? 50 has no square root. So 2 has no square root and 50 has no square root. So these are not square numbers. So what do? We can't do anything. But if we think of common factors again, there's a common factor here. 2 goes into 2 and 2 goes into 50. So we can factorize this as the type 1 or the common factor type of factorization, where 2 is a common factor. So when we factor out 2, we're going to have this, because 2 as a common factor, 2x squared divided by 2, it's x squared. Negative 50 divided by 2 is negative 25y squared. Okay, after that, we ask ourselves, okay, you don't have to be excited as if you are done, especially when you see this word. It should remind you that this factorization may involve more than one type of factorization. So you look here inside, you ask yourself, is there a common factor? No. But now it's a difference of two squares, because this is a square and 25 has a square root, which is 5. Okay, so now you can write it, you can factorize this now as difference of two squares, where x is the square root of x squared and 5y is the square root of, negative 5y, or should I just say 5y is the square root of 25y squared. So it's going to be x minus 5y in brackets, x plus 5y in brackets. Okay, well, the 2 is going to be outside. X minus 5y, x plus 5y. Okay, so we first did common factors, then here we did difference of two squares, hence we have this. So this marks the end of factorization type 2. Watch out for factorization type 3.